item, I'm going to talk about hash constructors, which are basically other ways of creating hash instances besides just using the hash literal syntax. Aside from using hashes in Ruby for many years, I did very little to actually prepare for this presentation, so it's going to be kind of minimal. But everybody should be familiar with the hash literal syntax, the normal way of creating hashes in Ruby. But there are other ways of creating them. For instance, equivalent to this hash literal syntax, roughly equivalent is using the subscript operator on the hash class itself. This will create the same hash. You can also, that's equivalent to just giving it a list of the keys and values all in one list. So you might wonder, well, why would I do that? And if you just have literal values like this, you wouldn't, but you might have the data actually, you might have the values as data coming in that you want, and you want to create the hash dynamically from that. It's kind of hard to understand why you do that with this example, but just pretend that this capitals data is actually like you read it in from a file or from a bunch of data in a database or something. So, and then we use the splat on the capitals data to actually make those, expand the array values out into arguments. So let's look at another example. So we have this hash that's the capitals by state, so I can ask the hash what's the capital for this state, but I want to say what state is this city the capital of. I want to basically just invert the hash, just switch the keys and values around. So we can do it the hard way, the brute force approach, by just creating a new hash and then iterating through the old hash and sticking the values in. But we Rubyists hate brute force verbose approaches like this. We want to do this simpler. So we could take one stab at it and just use map, just map the keys and values, just flip them around. This gets close, but the problem with this is map on any enumerable returns an array. In this case, it returns an array of key value pairs. So, so what we could do is take that and flatten it out into a single array and stick it in the capitals data and then create the hash the way we did before. That works. It's a little ugly. There's an easier way to do this. If you, the other way that the subscript operator on hash class works is if you actually give it an array of key value pairs, it understands what that is and creates the hash. So you actually don't need to flatten and then splat it out. You just give it the data. Or you can make it even shorter by just doing it inline. So this is actually the way to map over a hash and get a new hash back out. All right. What's next? Oh yes, okay, so new problem, and a new hash constructor. Say you want to, for this example, you have a list of words and you want to create a hash of each word with the number of times that word occurs in the list. So you just want to get a count hash of the word. So we can, again, do the brute force approach and iterate through it, and for each word, stick it in the hash. We can use this, this sort of ugly thing here to sort of create the default value of 0 if there's nothing in there, and add 1. But that's a little bit ugly. There's a more elegant way to do this. You can actually create use hash.new and give it a value, and that will actually be the default value. If you say hash.new with no argument, the default value is nil, so it's just like a normal empty hash. You can give it a default value, and so if you ask the hash for any value and it's not in the hash, you'll get that default. So that lets us simplify it to just say plus equals 1, and if there's not already a value, it'll be initialized to 0. Much more elegant. Slightly more complex problem. Say instead of just the counts, we want to group these words by the initial letter. And we can take the sort of same brute force approach where we're actually sticking this default value of an empty array in there, and looking up by the initial letter of the word, and if it's not in there, we default the value and then add the word to the array. Again, that's ugly. So we'd like to take a similar approach like we did before. So we could take a first stab and try to use what we did before. This actually will not work for two reasons. Number one, this is a single default value that will be returned every time. So every time the default value will be that same array. So one problem is we keep sticking every word in the same array. The other problem is that that value doesn't actually, in this case, that value actually doesn't end up in the hash at all. It's just the default value returned by the hash. So we can solve this problem in two steps. We can solve the first problem by using the block instead of just the value. And this time, every time we get the default value, it'll actually run this block and create a new array each time. So now we have a slightly different problem, is it will always be sticking the word into a new empty array. We'll be creating a bunch of empty arrays. We actually need to initialize the hash with that default value at that key. So what this version of hash.new actually does is it passes the hash itself and the key when it needs the default value, so you can use that to just stick the value into the hash. And this version works. So when we try to look up an array by the initial letter, if it's not there, it'll initialize it with an empty array. It'll actually stick it in the hash, and this works. Is that it? Oh yeah. So that's actually, this technique is actually a really good way to implement memoization. So here we have a linear implementation of a Fibonacci sequence. Basically it caches the computation of each Fibonacci number, so it never has to recalculate one. So we basically we get a hash of effectively all of the Fibonacci numbers. And I think that's it. Okay, so in summary, there are a lot of other ways of creating hashes other than hash literal syntax. You've got the subscript operator on hash class itself, where you just give it a bunch of keys and values. You can also use that subscript operator with an array of key value pairs. And then there's hash.new, giving it a default value, and then there's hash.new with a block that takes the hash and the key and an expression that you can use to stick the default value in the hash. And I have a couple of minutes for any questions.
Going back to the Fibonacci one, how would you create a hash for the first 10 Fibonacci numbers?
What's that?
So you would just call fibs bracket 10, and it would automatically calculate that spot.
Yeah, it'll calculate the 10th Fibonacci number, and in the process calculate all the previous ones between.
Right. That's awesome.
Yep.
Another question, just pointing out that using these alternate forms, especially like the bracket with the splat array in it, is a nice way to ensure that you have a hash. Like say when you're creating a method that takes a hash, you're not convinced that someone's going to necessarily send you a hash, and you can make sure you get one using that notation, which is kind of a nice way to do it.
That's a good idea, yeah. I didn't think about using it. But one point I wanted to mention, using this method of doing memoization on the hash is actually the most efficient way. It's way more efficient than doing the pipe by default thing to set default values.
My only comment would be that one of the shortcuts that you didn't show was, what if you have two arrays, one array of keys and one array of values, and you want to turn those two arrays into a single hash that maps the problem.
Put them in an array and do transpose and flip them around, but that would be a different lightning talk.
Or you could zip. There's a quick way.
Zip the arrays and then pass them in.
Yeah, you could zip too. Well, transpose and zip basically accomplish the same thing.
Do that.
Oh, one other point about using this method of memoization, it is not thread safe. So if you're dealing with memoizing values shared by multiple threads, don't do that. That's it, out of time.